Yo, it's your boy Jay Goo. I'm coming to you guys all summer long with this trigonometry ish. You hear me? By the end of the month of May, you should be able to help your son or your daughter with their trigonometry homework. Okay, so stop paying these tutors like myself to teach your children when you can teach them yourself. It's not hard. I'm going to try to make all of these videos as quick as possible, starting with chapter 1. Here we go. All right, trigonometry. All trigonometry is a bunch of angles, a bunch of sides, a bunch of notation, and a bunch of triangles. Okay, so boom, we need to know about these triangles. We need to know all that stuff that you probably was taught in class, but you was flirting with little Susie in the back. I remember you. I went to school with people like you. All right, so here we go. An obtuse angle. We're gonna start with these angles. An obtuse, and y'all gonna have to forgive my writing, all right? This ain't as easy as it look. All right, an obtuse angle is an angle that is greater than 90 degrees. So if you see this triangle sitting outside your stoop, that angle right there is an obtuse angle. Moving right along, we have an acute angle. Okay, and the acute angle is less than 90 degrees. Shit that's cute is small, right? Y'all like little cute shit, right? Which is a small angle. All of these angles here are less than 90 degrees, so we call them acute angles. Okay, popular questions on your kids' homework will be find the complementary angle. What is a complement? Right? Complementary angles, right? A complementary angle are two angles that add to 90 degrees. That's it. So if I have an angle, if the question says find the complementary angle to an angle B that is 30 degrees, the complementary angle is going to be 60 degrees, right? Because 60 plus 30 is 90. That's all that is. It's not hard. All right, next we have supplementary angles. Hold on. Forgive me, I ain't know the best spelling. John around, you know what I mean? All right, supplementary angles. Same thing, two angles, but they're going to add to 180. So similarly, on your kids' homework, if they ask you, find the supplementary angle of 90 degrees, your answer should be 90 degrees. 90 plus 90 is 180. All right, everybody can count. Okay. Notation. Notation is a big thing in mathematics. So you can understand all of this shit, but if it's overwhelming with all of these signs and things of that nature, then it could be confusing. So we have to get our notation down. All right. So when we're speaking about these angles, let's say we have this triangle here. All right. We're going to label the vertices. All right. All right. So when we want to talk about angle A, we denote it as such. So when you want to talk about an angle, you put it between the angle of concern, you put it in between the other two angles. All right. So this means we're talking about B to A to C, right? So B to A to C. So what's in the middle? A, right? When you go from B to A to C, right, you create this angle at A. So this is the notation for it. Similarly, you could talk about angle A by saying CAB. It gives you the same angle, right? You go from C to A to B. You create this angle A, okay? And if you want to talk about angle B, you would say A, B, C, right? You go from A to B to C, and you create this angle. All right, so that's notation. So you're going to have a bunch of this. If you had this, the angle of concern is angle B. All right, so remember that. That's notation. Moving right along. Angles will always be at the vertices in capital letters. Okay, so angle C is this angle. Angle B is such. Angle A is such. And you see here, they're denoted by all capital letters. Okay, all of these are capital. If you want to talk about these side lengths right here, okay, you use the lowercase letter of the opposite angle. So side A is here because it's opposite of angle A. Side C is lowercase and it's here, opposite of angle C. And lastly, side B will be lowercase across from the angle B. And that's how it will always be. Okay, these letters are subject to change, but the side will always be the corresponding side across from the angle or opposite the angle. You have to remember that. Okay, so side C will be across from angle C, side B will be across from angle B, side A will be across from angle A. Okay, so boom, we're almost done. All right, lastly, this chapter 1. All right, we have to talk about special triangles. So we have some special triangles. All right, and they are all familiar. I'm just going to give you a refresher. Okay, hold on, let me get myself some more room here. This is my second time doing this video. The first time I didn't have no audio. So this shit, it gets frustrating at times. But this is for y'all, you know what I mean? This is how I give back. All right. So boom. First of the special triangles is our equilateral triangle. Okay. Why is it special, Jordan? I will tell you. An equilateral triangle. What's the word you see here? Equal. Okay. So all of these sides are equal, which means their corresponding angles are equal as well. Okay, so an equilateral triangle has equal sides and equal angle measures. Okay, it's a tongue twister. All right, isosceles triangles is the next of our special triangles. What word do you see in isosceles? You see eyes. How many eyes do you have? Don't answer that because you might have one. All right. But most people have two eyes. All right. So how I remember it, two eyes means two sides. All right. So two sides are going to be the same. All right. And if you have two equal sides, well, that means you're going to have two equal angles, right? Opposite of those sides. So these are your two angles, right? And these are your two sides. Okay. Next, we have a scalene triangle. Now, there is no magic trick to remember in this one. You just got to remember that it's the oddball. Scalene, think reptile, think weird. I don't care what you think. But you must know that with the scalene triangle, all of the sides and angles are different. So this is what I'm going to put. I'm going to put different everything with an A. All right. Remember that. Everything is different. The sides and the angle measures. Okay. We got 3 more to go and we're done. All right. Bear with me. This for your children. Remember that. It's not about you. All right. Acute triangle. All right. An acute triangle. The only thing good about an acute triangle is that it has at least one acute angle. And remember, an acute angle is an angle that's less than 90 degrees. So as long as it has one angle that's acute, or I'm sorry, an acute triangle has all acute angles, right? So your equilateral would be an acute triangle, okay? So a triangle where all of the measures are under 90 degrees is an acute triangle. Forgive me for the mistake at first. Now, obtuse triangle is a triangle with at least, let's change this to all acute angles. Okay. Now, obtuse triangle has one obtuse angle. So this is the one where it has to have at least one obtuse angle that makes it an obtuse triangle. So one angle that's greater than 90 degrees. Okay. And lastly, of our special triangles, we have the right triangle. This is the classic triangle. This is the testable triangle. This is the triangle that you will never be able to get away from. It's everywhere in life. It has so many special properties. Okay, this right here is notation for a right angle. When you put that square in between two lines, that means that that angle is a right angle, which means that that angle measures 90 degrees. So when you have a triangle that has one 90-degree angle in it, it's considered a right triangle. Okay, and that, my friend, is it for chapter 1. The next time I post a video, it will be with practice problems over these things that we have just went over. It should not be too hard. I will see you next time. I'll holla.